Now children, we learn one of the first phenomenon as per the mass energy relation is concerned, that is called pair production. So this is important topic, children, for your ISC examination also, because it has asked many times in ISC. Now pair production is actually a phenomenon, a nuclear phenomenon, okay, in which energy is converted into what? Mass. So this is simply a what? A nuclear phenomenon. It is simply a nuclear phenomenon. Okay, it's a nuclear phenomenon in which energy is what? Converted. Energy is converted into what? Mass. Yes, as I said in the last video also, energy and mass in the universe are interrelated to each other. And in the universe, energy can be converted into mass, and mass can also be converted into energy. But a phenomenon which converts energy into mass on the nuclear level is called pair production. But it doesn't mean that all the energy get converted into mass. Okay, it takes place under nuclear phenomenon. That means this nuclear phenomenon occurs only under certain condition. Only under certain condition. And the important part on this pair production is the energy, okay, that is supplied, okay, to the substance must be a very high energy, a high energetic photon. So under this pair production to be observed, okay, so we basically see that an energetic gamma photon, you know, gamma ray is one of the light rays, okay. So when an energetic gamma ray photon, so let me just write down, when an energetic let me write, this is a sign of gamma ray photon, okay, falls, it exactly falls on a heavy substance, falls on a heavy what? Substance. Heavy substance means the substance which has high atomic mass and high atomic weight. So when energetic gamma ray photon, okay, gamma photon falls on a heavy substance, then this substance, okay, this substance absorb this energy. That means this energy is absorbed by the nucleus of the substance. So who will absorb the energy? The nucleus of the substance. So I write down, the energy is what? The energy is absorbed, okay, absorbed by the nucleus, of the substance. So when energy is absorbed by the nucleus of substance, then its energy give rise to the production of two particles. This energy give rise to the production of two particles. And two particles will produce, one particle is called electron. As you know, electron is one of the subatomic particle, a negative charge particle. But along with electron, what will also produce? A new antiparticle of electron will also produce, and that is called positron. So the discovery of positron, and one has an unstable particle, let me tell you, this is an unstable particle, can basically produce under the phenomenon called pair production. That means this phenomenon makes the energy can be converted into mass. But for the conversion of energy into mass, we can produce one of the unstable particle, that is called positron. So positron is unstable particle. Unstable particle. So this is the particle which is highly unstable and cannot remain in the atom, whereas electron is a stable particle. But positron is a what particle? Antiparticle. Antiparticle of what? Electron. So antiparticle electron means is a positive charge particle having same charge and mass as electron. Whereas you have proton. Proton is a positive charge, but the mass of proton and electron are not same. Whereas positron is a particle which has same mass and charge, opposite charge as electron. That's why it is also called antiparticle of positron, antiparticle of electron. That's why this particular phenomenon in which energy supplied to the substance get converted into the production of two particles in the form of mass of the particle is basically called as pair production. Now this pair production can be expressed by the relation, so by the equation. So the equation of pair production is given by h nu. Now I am writing h nu. You know, you have learned in photoelectric effect, every light has light particle, light has a radiation, okay, particle, and this particle present in light are called photons. The energy of each photon is given by what? H nu. So this is the energy of gamma photon. This is the energy of what? Gamma photon. So if this is the energy of what? Gamma photon, then this energy of gamma photon get converted into the two particles. That is one electron. Electron, we can write E minus 1 0 negative charge particle, and another particle which emit, that is called positron, which is E plus and 0. So children, this is electron and this is what? Positron. But you know, electron is also called a beta particles. Electron is also called beta particle. That's why we can also write this as beta minus 1 0, and positron can be written as beta plus 1 0. So this is also the symbol that we represent electron and positron. So energy get converted into the mass of electron and positron. So the production of this positron along with the electron, by converting this energy of gamma photon into mass, is called pair production. But as I said, this phenomenon occurs when this energy of gamma photon, okay, has to what? Fall on the heavy nucleus. So as for the relation concerned, so let me just show you with halo diagram. So this is the energy of gamma photon, and that energy is gamma h nu. So this is gamma photon. So when the energy of gamma photon exactly falls on one of the heavy nucleus. So let me just show you. This is a heavy nucleus. It can be of any nucleus but heavy nucleus. If the energy of gamma photon falls on the heavy nucleus having charge plus Ze, then from this nucleus what will emit? One of the particle will emit, that is called electron minus 1 0, and another particle even emit from this is called positron plus 1 0. So one is electron and positron, both emitted from this heavy nucleus by absorbing this energy by the nucleus. Okay, and this relation is only called pair production. Now one question arises out here. Okay, the question arises out here under this phenomenon is called, if the origin of positron, okay, and electron is due to the energy of gamma photon only, okay, gamma photon, then what is the necessity of the presence of this, the presence of this heavy nucleus? Now the answer is simply, if the nucleus is not present, just imagine, if the nucleus is not present, okay, then in pair production, both energy and momentum will not be conserved. Because when we talk about the pair production, it's not only the energy is conserved, the momentum is also conserved, because this photon always travels with a certain speed. So if a particle has a certain speed, it has a momentum also. Okay, so in order to follow the conservation of momentum, so this presence of this nucleus is very important. The presence of this heavy nucleus is actually due to, in order to have the conservation of both energy and the momentum. Now children, in this particular relation of pair production, according to Einstein's, a body in the state of rest also has some energy. In a universe, if a body is in motion or they are in motion or a position or it is at rest, anything, the body always has what? Some amount of energy. That means these are the particles, okay, which are usually at rest. Okay, so as for the Einstein's energy mass relation, okay, this particle also has energy, and this energy is called the rest mass energy. The rest mass what? Energy. But as I said already, the mass of electron and mass of positron is same, and the mass of electron is basically 9.1 into 10 minus 31 kg, and this mass is also called the rest mass. This is the mass called rest mass. Okay, and I consider this is the rest mass of the electron. Similarly, the mass of positron is also same, that is 9.1 into 10 minus 31 kg. So if electron and positron has same mass, then this electron also has energy, and this positron also has energy, and the energy of electron and positron remains same. Now we can calculate the rest mass energy of the electron and positron. And children, I write this rest mass of energy of electron and positron is MO. See, MO is the rest mass of electron also, MO is the rest mass of what? Positron also. So the energy, rest mass energy of the electron or positron can be calculated by EO. So I am writing EO. EO is the rest mass energy of okay, of electron or positron, and that is equals to MO into C square, because energy means mass into C square. So we can calculate now the value of rest mass energy. So m is 9.1 into 10 minus 31, okay, into speed is how much? 3 into 10 power 8 with whole square. Now we can do the calculation. So if you remove this bracket, so 3 square will be 9, so this is only 9.1, 8 to 10 power 8 square means 10 power 16. Now we can multiply these two and write this energy into power of 10 power minus 14. And children, if you do use calculator and calculate the value, you get approximately E naught equals to 8.2 into minus 14 joule. This is the rest mass energy of electron or positron. And but this energy we have calculated in joule. But children, let me tell you, the energy acquired by these particles we basically measure in mega electron volt. What? Mega electron volt. Which means there is a relation now. You know that 1 mega electron volt in one decimal place, if you round up, it will be 1.6 into 10 minus 13 joule. So look at it, 1 mega electron volt is always 1.6 into minus 13 joule. So to convert joule into mega electron volt, I divide by what? 1.6 minus 13. Okay, now let me just write down E naught equals to 8.2 into 10 power minus 14 divided by 1.6 into 10 minus 13. Now this energy which we calculate now in mega electron volt. So if you do the calculation, okay, so it will be 8.2 by 6, 1.6 into 10 power minus 14 plus 13. Okay, minus 14 plus 13. So how much it will be? 8.2 by 1.6 into 10 power minus 1. Okay, now 10 to the power minus 1 I'll take in the denominator. So 8.2 by 1.6 into 10. Okay, so 8.2 by 1.6 into 10 means 16. So 8.2 if you divide by 16, you get approximately 0.51 and the unit will be mega electron volt. So look at the energy of electron or positron, that is 0.51 electron, mega electron volt, sorry. So this is the energy acquired by what? The electron. See, if electron acquired this much energy, then positron also acquires same energy. So what is the total energy? So I can write down, therefore, the total energy of what? Electron and positron is nothing but 2 times 0.51 mega electron volt. See, you know why I multiply by 2? This is the energy acquired by electron. But there is positron also. So to calculate the total energy of electron and positron, just add 0.51 into 0.51, means 2 times of 0.51. So it will be 1.02 and the unit is mega electron volt. And this is the energy of this particle which emit under this pair production, electron and positron. But this energy, as for conservation of energy is concerned, this energy must be the energy supplied by the what? Photon, gamma photon. That's why for pair production, children, for pair production, it is essential that the energy of gamma photon, this energy is also the energy of what? Photon, gamma photon. So it is essential that the energy of gamma photon must be at least 1.02 mega electron volt. 1.02 mega electron. That means for pair production, the energy of gamma photon must be at least 1.02 mega electron volt. Now the question arises out here is, if the energy of gamma photon is less than this 1.02 mega electron volt, then what will happen? The pair production phenomenon will not be observed. That means positron will not liberate. Only electron will liberate. Only electron will emit from the nucleus. Okay. That means the phenomena like photoelectric effect, yes, the phenomena of photoelectric effect can be observed. So if the energy of gamma photon is less than 1.02 mega electron volt, so this will lead to the give to the definition of photoelectric effect. But the pair production will not observe. So for pair production to be observed, at least the energy of gamma photon must be 1.02 mega electron volt. If it is more than that, that is also okay, in which the positron along with electron will emit. But if the energy of gamma photon is less than 1.02 mega electron volt, only electron will emit, no positron will emit. So the discovery of positron or production positron can be done when the energy gamma photon must be at least 1.02 mega electron volt. And this particular phenomenon, which convert energy into mass, is called pair production. So in the next YouTube video, we go to the converse phenomenon of pair production, in which mass can be converted into energy also. And that is called pair annihilation. And you learn in the next YouTube video.